This is lesson 8.9, the final lesson in this unit. This lesson is about remembering exponent properties. We will also introduce some strategies you can use if you forget the exponent properties. First, here is a summary of the properties of powers and of square roots that we have learned this unit. Keep in mind that the square root properties also apply to cubed roots. If you come up against an example that you are unsure how to simplify, then you can use a strategy called testing a special case to verify how you are thinking the answer should go. For example, r to the third to the negative fourth power. You could be thinking it could be the sum of the exponents, leaving you with r to the third minus fourth power. Or you might be thinking you need to multiply the exponents, r to the third times the negative fourth power. You probably already know which one it is, but let's continue as if you were unsure. The first step to test a special case is to choose some number to test. In this example, I'm going to test r equals 3. You can try a different number alongside me to see if you still come up with a similar result. So I take my number that I chose, r equals 3, and I plug it in place of r, and I worked it out over here, you can see. So when I plug this into my calculator this way, I got 1.88 times 10 to the negative 6th power. This is how it may appear in your calculator screen. You can see I did 3 to the third, quantity to the negative 4th power. Whenever you see something that looks like this with an e and some number, this is scientific notation. It simply means this number times 10 to this power. From here on out, I will simply use the scientific notation. Just be aware that this is how it appears in your calculator. Now I plug in r equals 3 into both the left and right sides of this. So here I tried 3 in place of r, and then here I put 3 in place of r. And then I evaluated each side. The 3 to the 3 minus 4th power gives me 0.3 repeating, and 3 to the 3 times negative 4th power gives me this same result. So I know that I need to multiply my exponents to make sure I get something equivalent. Now let's try a different problem. Mark was not sure how to simplify the quantity x to the 23rd to the 6th power. He felt the answer could be either x to the 138th power or x to the 29th power, which is correct. So first I'm going to choose a value for x to test. Here again I'm going to choose x equals 3. It's a very simple number to test with. So I check my original problem, 3 to the 23rd to the 6th power. That got me 6.96 times 10 to the 65th power. Very big number. And now I'm going to check 3 in my two options here. So I have 3 to the 138th power and 3 to the 29th power. Now I evaluate. So 3 to the 138th, I got the same result as the original. So I know this is my answer here. So then for every x, then this problem simplifies to x to the 138th. Sometimes the numbers 0, 1, and 2 are not good for plugging in to check. Do not use 1, 2, and 3, 0, 1, and 2 as testing a special case. So let's see why. Is this pattern always true? X plus x equals x squared. We find that it is true when x equals 2. So if I plug in 2 in place of x, I have 2 plus 2 and 2 squared, and they both give me 4. But this pattern is not true for x equals 3. So 3 plus 3 is 6, and 3 squared is 9. A special case for which the answer is false is called a counterexample. So for this pattern, x plus x equals x squared, x equals 3 can be a counterexample for this problem. Let's try another one. Notice that 2 squared plus 2 squared equals 2 cubed because 4 plus 4 equals 8. And also 0 squared plus 0 squared equals 0 cubed. Can we conclude that x squared plus x squared always equals x cubed? So let's think about this. The numbers 0 and 2 seem to verify that the pattern is true. However, let's try checking a different number. I'm going to check x equals 3 again. I like checking with 3. So we plug it in, 3 squared plus 3 squared, and 3 cubed. Notice that these come from the left and right hand sides of this pattern. So now I evaluate. I get 9 plus 9 on the left and 27 on the right, and 9 plus 9 is 18. So x equals 3 is a counterexample for this pattern because it shows it to be false. So if you were asked what is a counterexample for this, you would say x equals 3. So for the rest of this lesson, all you need to do is practice using your exponent properties, and then practice finding counterexamples or testing special cases to show whether patterns are true or false.